Welcome back, students. In this video, we're going to cover lesson 3-6. I'm sorry, 6-3. I'm dyslexic, apparently. Medians and altitudes of triangles. It's going to be GR 1.3 and GR 3.3. Starting with our vocabulary. So, in a triangle, a median is a line segment with endpoints that are a vertex of a triangle and the midpoint of the opposite side. So, let's see. So, let me see. Vertex of this triangle, and it splits this in half. Vertex here, this splits this in half. And vertex here splits that one in half. The point of concurrency of the medians of the triangle is called the centroid. That's point W here in our example. And it's always inside the triangle. Not really sure why we needed to say that, but yeah, so angle bisector to, or vertex to bisect this segment here to here, same thing there. So theorem 6.7, centroid theorem. So the medians of a triangle intersect at a point called the centroid that is 2/3 the distance from each vertex to the midpoint of the opposite side. So what that is a ratio of 2 to 3. So over here in our example, so W is the centroid, so our distance from the vertex to the midpoint of the opposite side is 2/3. So this is a third and this is a third, or this is 2, this is 1 of our 2 to 1 ratio. So basically, to get our W, you would just multiply this by 2. So 20 times 2 is 40. That's 2/3 the distance from the vertex to here, and then the other third here. So, and then this would be 2/3. This is going to be double this. So, like this was double this. This is going to be double this. So half of 35 is 17 and a half. All right, let's see. This over here is a little example of the altitude. It goes from, I'm sorry, this is the median, not the altitude. Altitude's a little later. Actually, this is the altitude. That was the median up there. This is where I'm getting confused. Sorry, I had a text come in too. So, an altitude of a triangle is a segment from the vertex of the triangle to a line containing the opposite side and perpendicular to that side. So, see here, it's a straight line. And then over here, we have a dotted line because it's outside the triangle. Yeah, I guess that's why it said inside up there. Oh, let me see. If the three altitudes of a triangle are extended, they are concurrent at a point called the orthocenter. And that, I don't have that example here. It's going to be a little bit lower in the lesson. So yeah, the altitude goes from, so the vertex, and it's going to be perpendicular to this side. So see, this was straight. This is slanting because this side is slanting. But it's going to be, give you the 90-degree angle out here. So sometimes it'll be a dotted line and sometimes it won't. So let's get into the lesson part here. So example 2. So in triangle LMN, notice we have our congruent marks. In this triangle, PY, so this guy is 7. They want us to find LP. So for this triangle, P is the orthocenter. They're saying that PY is 7. So LP is from the vertex to the centroid. So this is your 2 to 1 ratio. So to get LP, we're just going to multiply PY by 2. PY is, of course, 7. So 2 times 7 is 14. So LP is 14. It's just that simple. All right, so you guys are going to do that with here. Your SP is 3.5. You're going to be looking for PZ. Let's come down the page. Example 3. Now we have this over here. We don't need the graph, but I may graph it for you just so you can see it. But it says, find the coordinates of the centroid of each triangle. Well, there's only one with the given vertices. So we have triangle PQR, and here are our vertices. Now, to find the centroid, there is a formula. Now, our book doesn't give it to us, but that's okay. The magic of the internet and a little bit of research tells us the x for the centroid, or x sub c, is going to be your x sub 1 plus your x sub 2 plus your x sub 3 divided by 3. So the x divided by 3, and then the y sub c, or your c for your centroid, is going to be y sub 1 plus y sub 2 plus y sub 3 divided by 3. So it's just going to be that simple. So your x's are -3, +3, +3. So let's just move this over. -3 plus 3 plus 3 divided by 3. All right, so -3 and +3 make 1. I'm sorry, they cancel. -3 and +3 are 0. I'm recording. Please go out. Shut the door. All right, so -3 and +3 cancel out. So that leaves us with 3 over 3. And 3 over 3 is 1. So our x coordinate is 1. All right, the y's. 1, 4, and -2. 1 plus 4 minus 2, because it's plus that, but plus -2 makes it -2. And then the 3 on the bottom. 1 plus 4 is 5. 5 minus 3. I'm sorry, 5 minus 2 is 3 over 3, which is also 1. So your centroid, the x was 1, the y was 1. So it's 1, 1. Very quickly, actually, let me pause, and I will graph it real quick. All right, so I went ahead and, so this is your, from here, -3, 1, this is your P. From here, +3, 4 is point Q, and then this makes point R. And then our centroid, so this is our center, so centroid is 1, 1. So our dot is right there. And that is the, I believe that's the geometric center of the triangle. I can't remember if it's that one or the orthocenter, but I'll pause in a minute and look. So there's your example 3, but we just used the formula. Much more helpful and easier than going that other direction. So top of the back page, we have example 3 check. You guys are going to use these coordinates with the formula I gave you on the opposite side, and you're going to find the centroid. All right, we're going to go down to example 4, and we're going to find the orthocenter. Now, this is a good bit more complicated. This is going to take a couple steps. So we're actually going to use the graph for room to operate here. So let me get my red pen. All right, so it gives us triangle ABC. Here's the vertices, and it says find the coordinates of the orthocenter. So the way you find the orthocenter, I'm going to write this here, and then we'll start doing it. So first you're going to find the slope. So in this case, you have triangle ABC. Okay. We don't have to find all 3. We just have to find 2 of these. So we're going to find the slope for AB. Once you find the slope for AB, then you find the slope for the altitude that's C to AB. Because if our triangle is ABC over here, A, B, C, AB to C is your altitude. So this altitude. This is remember, this is perpendicular. So it is the opposite reciprocal. So we find this to find this, plug it in to find the equation of the altitude. So you're going to do it, we're going to do AB, then it's C to AB, and then we're going to find the slope for BC, and then it's the the altitude A to CB. I'm sorry, A to BC. Then we'll just bear with me. Ugh. So let's find this slope first. So the slope for AB, and I wrote it MAB like that. So remember, it's our y's over our x's. So it's 4 minus 0 on the top, and then negative 2 minus 4 on the bottom. Okay, that's going to be 4 over negative 6, which is, it reduces to 2/3. So the slope for MAB is 2/3. Now, the slope for C to AB is the opposite reciprocal. So, how did I write this over? I'm just going to write M over here. It's going to be positive 3/2. Because this was negative 2/3, the opposite reciprocal is this. Now our point, we're going to use point C, because that's 0, 6. So I just brought that down here. We're going to use this to come up with the equation for the altitude using point slope formula. So y minus 6 equals the M 3/2 x minus the 0. All right. Hold on, can't even read my own writing here. Okay, yeah, so we're plugging this. What did I do? Give me just a second. I can't figure out what because it ends up being that, but I don't know. Okay, that's right, because this is 3/2 times x minus 0, so it's just 3/2 x. And then it's y minus 6, so you add 6 to both sides. So this ends up being the equation for this altitude. Now we're going to find the other one real quick. Excuse me. So this will be the slope of BC. All right, BC, so it's 6 minus 4 on top and 0 plus 2 on the bottom, because that's minus negative 2. All right, so that's going to be 2 over 2, which is the same as 1, right? So our slope for our altitude is going to be negative 1, because it's the opposite reciprocal. 1 over 1, this would just be negative 1 over 1, which is also negative 1. And this was this is A to BC, so we're going to use point A. Point A is 4, 0. So we have negative, so let's put that over here. So y minus 0, or it's just y, like we did here, equals negative x, and then plus 4. Yep, so this is the altitude, this is the equation for this altitude. So all this to get these two guys. Now we're going to put these equal to each other to get our x coordinate of the orthocenter. So let me just do this. So y equals negative x plus 4. I'm sorry, it's negative 4x plus 4. Remember, we're skipping the y part. Equals 3/2 x plus 6. So again, this will give us our x coordinate, and then our x we're going to plug into either one of these and it'll give us the y. So we have 3/2 x and minus x. Let's add the x to both sides. So these cancel. We got 4 equals. Now 3/2 x plus x, this would be the same as 2/2. So 2/2 plus 3/2 is 5/2 x. plus 6. Let's subtract the 6, subtract the 6. So you get 5/2 x equals -2. And then when you divide both sides by 5/2, which is 2.5, you get 2 over 2.5, which is the same as x equals -4/5. So now we have x equals -4/5 off the screen. So down here, orthocenter. So the x was -4/5. Now I'm running out of room to plug in the y. Yeah, where did I do that? It's okay. We will find a spot. So we're going to put our y here. Let's use this little area here. So we're going to take this guy. So y equals -x, so which would be +4/5 plus 4. 4 plus 4. All right, so 4/5. 4 is the same as 20 over 5, right? So 20 over 5 plus 4 over 5 is going to give us 24 over 5. So our orthocenter is -4/5, and our y coordinate is 24/5. Like I said, I know that was kind of choppy and rough. It's a lot of steps. Comment on the video or send me a message or ask me in class, and we'll work on that. The example 4 check. So you guys are going to do what I did. So you're going to take, so I'm just going to write it. So slope for GH, and that'll give you the slope for the F to GH. You'll do so you do that. And then take the point, which in this case, F, -2, 4, and then that slope, and plug it in your what is it? How is it written? You plug your y in here and you plug your x in here. So you'll get once you get your equation for F to GH, then you're going to do it again. Do the same thing again, but this time for, so if it's FGH, so F to GH, and then you could say G to FH. How about, so G, so find the slope of FH, then get the slope of that G to FH. Plug it in here and do the same thing there. I'm sure I probably lost you. Hopefully not. If you need to, rewind. I said if you need to see me, please see me. At the bottom, so our point of concurrency of the medians of a triangle is called the centroid, and it's always inside, it says inside the circle. God, inside the triangle. So, until next time, have a good night.